Alright my friends, we have pretty much finished almost the entire series if you have been able to stay with me the entire time. Now again, I have to tell you I'm sorry if my voice has not been as enthusiastic as always. You have to understand, I almost died last Thursday getting an elbow to the throat, which makes it hard for me to speak. Matter of fact, it hurts to talk right now, but I'm doing this for you, for your education. Alright, let us begin. First things first, my friends. I wanted to cover, we just went over logarithms and all those properties, and I wanted to show you, you remember y is equal to e to the x. Well, what is the logarithmic form of that? Well, the logarithmic form is ln of x. ln, okay? And we have ln of x. It turns out ln of x is just a logarithm, correct? It's just another logarithm specifically just for e to the x, the base e. So the logarithm property still applies. So if you have ln of a plus ln of b, well, that would be ln of a times b. And if I have ln of a minus ln of c, that's just ln of a divided by c. It does not matter. It's still the same because ln is a logarithm. It's just a special version for e, the special inverse for e, base e. And you have a times ln of a. That's just ln of a to the c. Same exact properties, just different. So let's just go through some example problems. Let me just show you. Let's say we have ln of 4 plus ln of x plus ln of z. Well, I want you to observe these are all plus signs, so that means multiply. So that's just 4 times x times z. So now I know this is going to be ln of 4xz, just multiplying in there. All right, well, let's try ln of x minus ln of y plus ln of x. Okay, well, I know because this expression right here has a minus sign, this is going to mean divide the x and the y. So I'm going to get ln of x divided by y plus ln of x. Well, what does a plus sign mean? That means multiply. So I'm going to get ln of x over y times x. Well, is the x on the top or the bottom? Well, the x is on the numerator, the top. So this thing is just going to become ln. Well, x times x is just going to be x squared over y. Perfect. You can see it's the same thing. Let's try expanding. Let's say I have ln of y squared times x. Well, this is just going to become ln of y squared plus ln of x, just kind of expanding it out. And because I have this exponent of 2, I can just pull it out. And so this whole thing is just going to become 2 times ln of y plus ln of x. You can see the properties are the same. It's just ln. All right, let's try maybe something like this right here. Let's say I have ln of the square root of x, y, z. Well, this is the same thing as ln of, well, this is x, y, z. This is all raised to the 1/2, right? There's like a, if it doesn't show it, it's an invisible 2. Well, what can I do now? Well, I can pull the 1/2 out. So if I pull the 1/2 out from the ln, I'm going to get 1/2 times ln, and we have x, y, z in here. All right, well, this is all multiplying. So to expand that out, we're going to get 1/2. I'm going to put a big parentheses. It's going to be ln of x plus ln of y plus ln of z. And now what I can do is I can distribute the 1/2 to every expression. 1/2 times ln of x is the 1/2 ln of x plus 1/2 times ln of y is 1/2 ln of y plus 1/2 times the ln of z. So it's going to be 1/2 ln of z. So those are the only ones that can get a little bit tricky when you're expanding it out because you have to distribute that across to each one. All right, cool. Well, with that being said, I think that wraps it up. Before you go to the exceeding level portion, you have yourself a fantastic day yet again. Take care.